Okay, good day. Welcome to our recorded video. So I will now record a sample problem about a multiple charges shown on the screen. So for example, we have three charges at point A, which is positive 5 microcoulombs, and at point B, which is negative 2 microcoulombs, and at point C, which is positive 3 microcoulombs, are arranged at the corners of the right triangle as shown on the image. Then what is the net force on charge C? For this example, we will just determine the force exerted at point C. So, charges A and B both exert on force C. Diba? Meron tayong A na force. Yung force ng A, meron tayong effect dyan. Saka force ng B papunta kay C. So, as you can see, parehong positive. So, eto, magre-repel. So, may force na magre-repel dito. At dito, positive to at negative naman to. Ito naman yung force na mag-a-attract. So, although A and B exert forces on each other, so these forces have no effect on the forces that they exert on C. As you can see naman, yung line of action ng A and C, ito. So, wala naman siyang effect sa ating A and B, walang effect siya sa C natin. The net force on charge C is a vector sum of the two forces exerted by charges A and B, like I said before. And the forces exerted by A and B are related to magnitude of the charges and distance between the charges according to the Coulomb law. So, identify the goal. Hinahanap natin yung pinaka-net force. So, ibig sabihin summation forces on C o summation of charges at point C. So, first, let's draw our free body diagram. So, ito yung point C natin. At like I said nga, meron tayong repulsion dito from force EC. At meron tayong attraction from force BC. So first, we need to identify these forces. So ito muna hanapin natin. After natin mahanap yan, saka natin makuha yung net force at force C. So let's find first the net force at force BC. So force BC is equal to K, the constant, times the charge 1, then charge 2, absolute value of them, and R squared. So, K is 9 times 10 raised to 9 multiplied by the absolute value of the first charge. So, pwede nating first charge to, then second charge to. And take note, no, pag sinabi microcoulombs is equivalent to 10 raised to negative 6. So, we can apply it now. So, 3 times 10 raised to negative 6 multiplied by 2 times 10 to raised to negative 6. Then Coulomb squared na to divided by, take note, our R here is 0.02 meters. So, kakonvert po natin siya. So, meron tayong 0.02 meters squared. So, using our calculator, we're able to find the value of our force BC. So, we have 9 times raised to 9 multiplied by 3 times raised to negative 6 times 2 times raised to negative 6, 2 times 10 raised to negative 6, all over 0.2 squared. So we have a force or a Newton of 135. So force BC is 135 Newton. Okay? Next, let's have our force AC. So force AC is equivalent to K using our Coulomb's law. So absolute value of Q1, Q2 all over R squared. So dito naman po tayo titingin. So ang nangyari lang po, meron tayong 5 cm or equivalent siya sa 0.05. Then repulsion siya. So let's have our first Q, yung 3 microcoulomb. So 9 times 10 raised to 9 multiply by microcoulombs na 3 times raised to negative 6 multiply by positive 5 10 times 10 raised to negative 6 divided by 0.05 meters squared. Let's put the unit. Okay? So using our calculator, let's change na lang to ng 5. Then ito ay change natin ng 0.5. So we are able to get the value of AC na equal kay 54 Newton. So if you can recall our P61, so summation forces along X and Y. So para makuha po yan, di ba, summation of force is equal to square root of so the net force na lang para mas madali. Force is equal to square root of force acting at x-axis plus summation of force acting at y. And don't forget to square them. So yun po yun. So as you can see, wala naman pong angle, so we can directly solve it na. So our force will become square root of our fx. So ang fx natin yung along kay x. So obviously ang fx natin dito ay 135 Newton. Dito naman yung 54 Newton. So meron tayong 135 squared plus 54 squared. Then ang unit niya nga ay Newton. Okay. And solving it, so force will become is square root of 135 squared plus 54 squared. So we're able to get 1.45.3994 Newton, or equivalent na lang siya sa 14.5 or 14 Newton. So I can accept this answer na. Then as you can see, if you can recall, may resultant force po yan na nandito. So tinatanong kung anong angle ito. So to find that angle, so let's use the tangent theta is equal to the value in y divided by x, or theta will become inverse tan of y over x. Ang y natin ay 54. So inverse tan 54 divided by 135. So our value of theta is equal to inverse tan of 54 divided by 135. So we can get a 21.80 degrees. And it is clockwise. So pag clockwise, possible pwedeng negative. Negative kasi di ba po, if you can recall, ang angle natin, positive po yung paganyan. Clockwise nga po. So pag papunta dyan, magiging negative yung value natin. Pero kung may nakalagay naman tayong clockwise, pwede na po yan. Therefore, we can conclude the net force on charge C is 145.14 Newton at angle 21.80 degrees clockwise from the horizontal. Okay? So, possible on your problem set, ang mangyari lang dyan, merong angle. So, kapag may angle, you will just apply the component method. Okay, that's all for today. So, goodbye.